Hello and welcome to Apologetics 101. I'm your host, Brian, and we're here today discussing the age of the universe with Dr. Jason Lisle. I can't wait. Let's dive right in. Well, hello. I am with today Dr. Jason Lisle, and we're going to be discussing the age of the universe today. I know that's a little bit out of order that we normally do because the way I was planning to do this series is that I was going to do the age of the earth stuff when we get to chapter 5 of Genesis. But I know Dr. Lau is limited on his time, and so right now he's got some time to do this, but he might not have that time later. So we're going to go ahead and do one on the age of the universe with Dr. Jason Lau. And I know, Dr. Lau, most people know who you are, but I usually like to, for someone to get, introduction because, well, someone might have been living on another planet or something. So they might not know who you are. So, they might have been on the Russian space station or something. So,
Right.
could you give a introduction and also, if you want to say a bit about your ministry, Biblical Science Institute?
Sure. Yeah, I'm Jason Lisle. I'm the president and founder of the Biblical Science Institute. We're a Christian ministry dedicated to confirming what the Bible teaches, showing how science confirms what the Bible teaches, and refuting the secular narrative. I myself am an astrophysicist and a Christian. I was saved when I was very young, 6 or 7 years old, and I've never had any reason to doubt that. I love the Lord, and I've dedicated my life to trying to defend His word and proclaiming His gospel. And I went in terms of my education. I have a master's degree and a PhD in astrophysics from the University of Colorado in Boulder. And for the last 20 years, I've been doing full-time creation apologetics ministry, showing people how the Bible, how science confirms what the Bible teaches, particularly in matters of science and origins. Biblical Science Institute, you can check us out on the web, biblicalscienceinstitute.com. And that's really where most of my articles, books, DVDs, and everything else you can find that I've written or spoken on, you can find that on that website.
I'll also have a link in the description box below. A lot has changed on my channel since last time you've been on there. The I don't know if you saw how many people's viewed the distant starlight video that we did, but it blew up on the internet.
Oh, great.
So it's
Good.
like over four. It's still the highest ranking video on my channel. It's like over
Oh, well,
four
that's
thousand views. So a lot of people like that video. There's some critics, of course, that showed up that didn't like it, but most people did, and it's a real popular video.
oh,
Um,
good.
yep, my Genesis series kind of went popular, so after that, but that was a really good video that we did. I know that we did not in that video, but in the origins of the universe video on the the secular view of the Big Bang and stuff. I know we did talk a little bit about the age of the universe there, but we'll probably rehash some of those this time around.
Okay.
But this time it's going to be specifically about that, so we can be able to go a little bit more in detail or something.
Okay.
Um, all right. For my first question, I would like to know what is uniformitarianism? I know that is a view that regulates and drives the assumptions behind the age of the universe and well, basically the age of anything involving creation, including the age of the earth. So, what is that concept? And I guess to also speak on its unbiblical nature.
Okay. Uniformitarianism is the belief that the present is the key to the past, and in particular, that present rates and present conditions are indicative of past rates and past conditions. With regard to geology, which is where it's heavily influenced the field of geology, particularly in secular geology. It's the belief that present Earth's features that we see today, mountains, canyons, things like that, have been formed by the same kinds of slow and gradual processes that are taking place today. And so the uplift of mountains that's produced by plate tectonics, that's quite slow today. The uniformitarian assumption would be that it always has been. And therefore, mountains must be, many millions of years old at least, because if they start, assuming they started from nothing, it takes so long at the present rates for them to build up. One of the things that uniformitarianism ignores is the worldwide flood. In fact, a Genesis flood that floods the whole earth, I mean, that's going to do all kinds of damage. That's going to have erosion rates that are many orders of magnitude greater than the erosion rates today. And so a person who holds tightly to uniformitarianism could not accept the possibility of a worldwide flood. They can't even accept it as a possibility because it's contrary to uniformitarianism. A worldwide flood would rapidly deposit all kinds of, sediment and things like that, things that today would take a very long period of time because we're not having worldwide floods today. So that's probably the classic example of uniformitarianism, one that's mentioned in one of Peter's epistles, 2 Peter chapter 3, where he talks about the people being willingly ignorant, that they say all things have continued as they were from the beginning of creation, and they deny a worldwide flood because that's not happening today. God's judgment on that kind of scale is not happening today, and so therefore the assumption is it never did. That's uniformitarianism in a nutshell. Present rates and conditions, the rate at which canyons erode today has always been that rate. The rate at which mountains are pushed up today has always been that rate. That's not a scientific conclusion. It is a philosophical assumption that drives the conclusions that people draw when they go and then look at the evidence.
Yeah. And of course, the uniformitarian assumption actually filters over into other disciplines. Hugh Ross
It does.
has tried to argue that the expansion rate, and based on the rate in which it expands outward, you measure that, and then they say that that measures to like 14 billion years. Of course, that actually assumes the Big Bang Theory and assumes that it started with zero size. So,
Yes,
and Ross knows this, so he tries to argue that well, we know that he uses the word no, but he said we know that the universe started relatively small, and it's like how do you know that?
he doesn't. Yeah, he doesn't. And that's the other assumption is naturalism. Uniformitarianism and naturalism are the driving assumptions that secularists make when they interpret data regarding origins. And so even if you assume the universe has expanded at the same rate that it has today, or the same basic kind of rate, I mean, they allow for gradual changes. That doesn't mean it started with zero size. That's a naturalistic assumption. God could have created it just like he says a few thousand years ago, even if the expansion rate hasn't changed. He could have created it like it was a few thousand, just like it is today, a little bit smaller a few thousand years ago. That's perfectly consistent with the data. It's not consistent with the assumption of naturalism and or uniformitarianism.
Didn't the guy that I forgot his name, the one who formulated the Big Bang Theory, and then he originally suggested that, but then because of his philosophy
Yep.
of ignoring, that God has anything to do with anything, so that he just kind of said, nope, we can't use God. And so,
Yeah, George Lemaitre, who came up with the Big Bang. Well, he initially thought the universe was expanding and that it started from a finite size, which is, that's pretty close to the truth. Although there's new evidence that suggests that the expansion isn't exactly what we thought it was anyway. But then in 1931, he said, you know what? Maybe it all went back to a point, a long time ago. And that was because he was a methodological naturalist. He did believe in God, but he believed that you should pretend that God doesn't exist when you're doing your science, which is methodological naturalism. So that's the birth of the Big Bang. It is an atheistic or a methodological atheistic model.
doesn't really make a whole lot of sense since science is actually founded on the existence of God and Christian worldview. So it doesn't
Yeah.
make a lot of sense to ignore the existence of God. It's like it's kind of like yes, I believe Jason Lisle exists, but let's pretend he doesn't, and then ignore all the stuff that he's actually done. It's like,
Yeah.
but he did do that. So,
Yeah. I agree. Yeah, I agree.
but anyway, all right. But before we move on, I do want to ask you something about there is a distinction because me and you are both presuppositionalists, and there's this distinction between uniformity of nature and uniformitarianism. And I've seen Hugh Ross and others confuse those two. And that's part of the reason why they think we're somehow violating the laws of physics or something. And we'll get into that later. I was wanting to speak to that distinction between the uniformity of nature versus what uniformitarianism is.
Right. Yeah. So yeah, uniformitarianism deals with rates and conditions. It's assuming the present's the key to the past. If mountains are building up slowly today, the assumption is they always have. Uniformity is different. Uniformity simply means that there are rules in nature, there are laws of nature that don't arbitrarily change with time, and that's predicated on the biblical promise that God has built in certain cycles into nature, like the day and night cycle, the seasons that He promises will not change, and that's given in Genesis 8:22 after the flood, where there was an apparent eruption of these cycles. Uniformity is more basic. It's basically saying the laws of nature don't arbitrarily change. It does allow for miracles. I don't believe in an absolute uniformity in nature. I believe that God can multiply loaves and fishes if He wants to,
Right.
but normally mass is constant, so on. But that doesn't mean that the rates and conditions have never changed. I mean, the worldwide flood, as far as we know, it didn't change any laws of physics or laws of nature. It's just that the rate of erosion would have been much higher. So the global flood is against uniformitarianism, but it's perfectly compatible with uniformity because there was still a day-night cycle, that the basic laws of nature remained unchanged as far as we know. So they are distinct. They're related, but they're distinct.
Yeah. So there could be in certain situations where something might be constant, but it's not would not be true to say it would should be arbitrarily assumed as much. Um, and
Right.
interesting enough, we're about to get into some arguments later concerning that. But one of the things that I found is that a lot of times uniformitarianists will abandon their uniformitarian assumptions when they're encountering evidence that goes against it, and it's not consistent with it. And we'll talk more about that later. I've noticed that as well on the uniformitarianism. All right. Now let's talk about the one that contrasts with that, catastrophicism. What
Yeah.
is catastrophicism?
Yeah, or catastrophism. Catastrophism is the belief that, well, when it comes to geology, let's limit it to geology for the sake of argument. It's the belief that the majority of Earth's features were not formed by the kinds of slow and gradual processes we see today, but were formed under conditions that were much more extreme than the kind of conditions that we see today. And so, biblical creationists would tend to hold to a catastrophic view of Earth's features. We believe there was a worldwide flood. According to Psalm 104, the mountains rose, the valleys sank at the end of the flood, and so that would have happened rapidly. And so the things like mountains, we don't believe that they took millions of years to form, because we believe they formed rapidly at the time of the modern mountains. We think were formed during the flood year. There were mountains before the flood, but we think they were much smaller than the mountains that exist today, like the Rocky Mountains. When I look out my window and see the Rocky Mountains, we think those are produced toward the end of the flood rapidly, because there were catastrophic conditions that would have made plate tectonics much faster, orders of magnitude faster than it occurs today. There is evidence that the rate at which nuclear decay happened was faster in the past. Perhaps in that we think that's related to the worldwide flood, perhaps, but that would be a catastrophic condition. It's much faster. It's orders. So the condition, it's not that the laws of nature necessarily changed, but the conditions were different, such that things that today happen at very slow rates in the past would have happened at rapid rates. So that would be catastrophism. That would be the view that I believe the Bible endorses, at least when it comes to Earth's geology.
Um, I would say like the uniformitarianism would be like assuming that if a particular area, let's say a particular area erodes at a certain rate, then it's always eroded at that rate. But what if there was
Yes.
conditions that affected the rate, such as higher flood areas? And of course, the global flood would obviously cause lots and lots of erosion. And so
Right.
those kinds of conditions, as soon as you change those conditions, you change the rate because you increase the amount that's actually occurring. And so
Yeah,
that's essentially
exactly.
what we're saying. All right.
Right.
What is age? I've heard you talk about this in the debate before. Age is a concept of history, a concept of time. Is that correct?
It is. Yeah, age is basically it's the present time minus the time of origin of an object. So if you want to know the age of something, you look at your watch to find the present time, and then you subtract the time at which that object came into existence. And the difference between those two numbers is the age. And so it's a concept. It's a concept of history.
I remember in a debate with Hugh Ross that you had, you mentioned T1 and T2. I like the way you had framed that. In order to do science, you need both T1 and T2. If you
Yep.
only have one point, if you only have one data point, then you're not really doing science as a result. And
Yeah, or you can't calculate an age unless you have both T1 and T2, the initial time and then the current time. You can't calculate age. That's right.
yeah, but with that doesn't mean you can't know it. You can have a historical source, like someone's birth certificate or whatnot, or in our case, the Bible. You can have a historical source that can tell you. But
Right. That gives you the initial time, and then you subtract or you subtract that from the current time. That gives you the age.
but you're also doing history at that point, which is
Right.
what, yeah. So yeah, my next question is, does the universe look old or look young? Does either of these make the reification fallacy?
Yeah. If it's used in an argument, if you want to say, I know the universe is old, or I suspect it's old because it looks old, that's a reification fallacy. Because as we just talked about, age is a concept. It's a concept of subtracting two numbers. Now, that is not something you can see. You can't see age. And the reason people think they can is because we tend to use that reification in everyday society when we say a person looks a certain age, but we're not being literal because you can't see a person's age. What you can see are the person's physical characteristics. And we kind of know that certain physical characteristics are typical of an age. And so we're not looking at age, we're looking at what's called a proxy. A proxy is something that represents something else. And so if I encounter a person that's got very gray hair and lots of liver spots and lots of wrinkles, I might say that person has a great deal of age. I'm guessing that that person's the present time minus the person's time of origin is quite a large number. And that would probably be correct, but I'm not seeing age. I'm seeing physical characteristics that we tend to associate with age. And so if you think about that, that works with people because we people generally acquire physical characteristics. They tend to go gray, not at exactly the same rate. There's some variation, which is why you can say you look young for your age. And that's always a nice thing to hear. But that means that the proxies don't exactly match the actual age of something. But you can't do that with the universe. You can't say, well, if I've looked at all the universes that I've seen, this one looks, it has physical characteristics that are typical of a 13 billion year old universe. You can't say that because we've only got the one universe. That's it. It's not like we've got 20 whose ages are known. And so we know what physical characteristics are associated with a universe of a given age. You can't do that with the universe. So even that sort of metaphorical usage, and I'm not saying it's wrong to do that with people, but when you start doing it with rocks or the universe, then it becomes a fallacy, and it is a reification fallacy. The universe doesn't look old or young, it just looks the way it looks. Now, I could poetically say, well, the universe looks young, but what I mean by that is it has characteristics, physical characteristics that are typical of youth, like things like lots of blue stars, which mathematically we compute can't last billions of years. So I could say that, but I tend to avoid that kind of language just to be perfectly, just so there's no confusion. I don't want to be accused of a reification fallacy myself. So when someone says they think the universe looks old or that it looks young, they're not really telling me much about the universe. They're telling me about their presuppositions. They're telling me about the philosophy that they take to the universe when they look at the evidence. It's very revealing of their worldview more than it is about any specific evidence.
Of course, Hugh Ross, when he uses it, he actually uses it as an argument because he actually thinks the universe looks old. And
Yeah,
so
and
that,
that is a reification fallacy. Yeah.
right. And speaking of age, next week's my birthday. I'll
Oh,
be
happy birthday.
47. Thank you.
All right.
Actually, you have an interview with a buddy of mine, Donnie Badinsky from Standing for Truth. He's also subscribed to my channel, so he's probably watching this now. But I mean, whenever I upload it to YouTube. But it's on August 12th, and that's how I remember y'all's because it's on my birthday.
Oh, that's cool.
But I have the night off, so I'll be able to watch that interview. You'll see me in the live chat if you look at the live chat. But anyway, but speaking of age, I'm 47 and I'll be 47, and I don't look it, but I was thinking that when you said that. So, but anyway, all right. So basically, it would commit the reification fallacy. We don't have an actual another universe which we can compare this universe to, and say that looks young. Say, hey, look, it's younger than this universe, but older than this universe. We don't have that.
Right.
All we have is this universe.
Right. Right. You can't literally see age, and all you can see are characteristics that are associated with age, but we don't know what an old universe looks like because we've never seen one. And that's what I told Hugh Ross the last time he made that mistake. I said, because he's talking about, well, the stars look old. And I said, how do you know? You've never seen an old star. How do you know what an old star looks like? You've never seen one.
All right. What is the best evidence for the age of creation? Me and you're both presuppositionalists. I already know the answer to that question, but go ahead.
I'm sure you do. Yeah, the Bible is the best evidence we have because it's the birth certificate of the universe. It's an historical record that records the events that happened at the time of creation and gives us enough information to calculate the time between creation and Christ's earthly ministry. For example, we know that there's about 4,000 years between those two. And from other historical records, we know that was about a little over 2,000 years ago. So that puts the universe at a little over 6,000 years old. And that's the best way to know the age of something is if you have documentation of its origin. And the Bible is really, the Bible's the only documentation we have of the origin of the universe. There are creation myths in other cultures that speculate on how the universe came into existence, but the Bible's the only one that was written by an eyewitness, inspired ultimately by God, the ultimate eyewitness, and made in 6 days. That was written. The fact that God created everything in 6 days is part of the Ten Commandments. It's written by the finger of God in stone. So we have eyewitness testimony of God Himself, who can't be mistaken about anything, otherwise He wouldn't be God, of the origin of the universe, and that gives us T1. And so we know T2 that we can subtract, we can get an age of a few thousand years based on primarily biblical data. You could argue about the 2,000 years between Christ's earthly ministry and now, but no one really disputes that. So that puts the age of the universe at a few thousand years, and that is the best evidence, and it is evidence of the age of the universe, and it's the best because it's irrefutable. It's the inerrant word of God.
Right. And I got your book right here. If anyone Taking Back Astronomy. Um, Actually, I was going to quote from it, but you already worded it that
Did
way.
I? Okay.
Yeah. Because I was just reading that before the interview, what you wrote in your book, Taking Back Astronomy. So yeah, I know that book's a little old, but when you were talking about the age of the universe with the Bible, you uh referenced that, and I know the Bible don't change, so I'm
That's
pretty
right.
sure your position wouldn't change on it.
Right. Right
But
on.
all right, what what is a reductio ad absurdum argument? That's going to come up, in a little bit because we're going to be doing that essentially. But can you
Mhm.
describe that for us?
Yeah, reductio ad absurdum, that's Latin, means reduction to absurdity. It's where you basically, for the sake of hypothesis, you assume your opponent's position and show that logically, if you follow it to its conclusion, it would lead to a conclusion that is absurd, one that is perhaps contradictory to the starting assumption. And we can take a look later on and see how that's applied. But it's a very, very powerful way of arguing. It's a very good way of arguing. It's a biblically authorized way of arguing, I would say, where you don't. It's where you have a fundamental disagreement with someone, and you think their position, their philosophy is just fundamentally wrong, and you can't get anywhere by just sharing evidence with them because they interpret the evidence according to their philosophy. What you can do is you can say, although I don't embrace your philosophy, hypothetically, if it were true, it would lead to this, which would lead to this, which would lead to this, which contradicts the very philosophy you're espousing. And so if you do it right, you can show that worldviews that are contrary to God's word lead to positions that are absurd. They would make knowledge impossible, or they would refute themselves. And because many of these chains lead to a self-refutation, that's powerful. Because what's the person to do then? If he sticks with his philosophy is wrong because it contradicts itself. If he abandons it, well, then that's what we want. We want him to abandon that because it's wrong, and so he can't stand on it anymore. It is a very powerful way of refuting an absurd position by showing that if you hold to that consistently, it will lead to an absurd conclusion, one that the person holding this position could not possibly hold to. Very powerful way of arguing.
Yes, it is. In my opinion, it's one of the most powerful ways to argue and a way to avoid circular reasoning, assuming your position in arguing against their position. Um, which brings me, yeah, well, it's not my next question, but I'll ask it anyhow. Um, on reductio ad absurdum argument, is there any arguments that old earthers make that that do a reductio ad absurdum argument, or do all of their arguments tend to assume the position while arguing against ours?
Yeah, that's a good question. I've noticed that, in my opinion, there are no old earth arguments that properly use a reductio ad absurdum. None. And that's very revealing, because when we try to argue on the basis of science, that science confirms the biblical age of the universe, we usually do a reductio ad absurdum. We usually assume the old earth assumptions of uniformitarianism and various degrees of naturalism, and then show that that leads to an inconsistency. We show that even if you assume millions of years, deep time, slow gradual rates, there are still certain evidences that when you apply that, you get a young age. And so you can't, it's like it's inconsistent with itself. We tend to use reductio ad absurdum properly to show that the old earth assumptions of uniformitarianism and naturalism lead to a conclusion that is incompatible with old earth beliefs. They lead to a young earth anyway. It would be nice if the old earthers, it would be logical for them to do the same, to say, we're going to assume a supernatural creation, we're going to assume catastrophism, and show that that leads to an inconsistency. But they can't do it because it leads to consistency. If you assume a supernatural creation and that there was a worldwide flood, we find that that readily explains the evidence that we find. When we do age estimates, we find they're consistent with the biblical time scale of thousands of years. And so I would argue that really all old earth arguments are ultimately beg the question. They ultimately assume the very philosophy that they're trying to prop up by the evidence. They don't realize they're doing that, or because nobody wants to be accused of a vicious circular reasoning. But I would argue that old earth creationists and evolutionists do that. They assume uniformitarianism, naturalism, and then they argue that the evidence then proves uniformitarian and naturalism old earth. They assume old earth assumptions and then show that when those assumptions are followed, in many instances, they lead to an old earth. But that's the very assumption they started with. That doesn't prove anything. They should use a reductio ad absurdum. They should assume supernatural creation and catastrophism and show that that leads to an inconsistency, but they can't because it doesn't.
Right. Absolutely. To argue that the universe started out relatively small would have to assume that special creation, the idea that God spoke everything instantaneously into being, was wrong, and that the galaxies and stars formed over time. Because there's no way you could take the universe as it is right now and squeeze it into such a small space. So you'd have to sit there and assume your position of natural formation of the galaxies and stars.
Yeah, that's right. And that's what Big Bang folks do. They assume uniformitarianism, naturalism, and then show that that leads to millions of years. But those things are all baked in together. They all go together. We would reject uniformitarianism and naturalism, and so there's no reason for us to believe in the millions of years.
Right. Although this discussion is not on presuppositionalism, I would like to ask, as a Christian and someone who wants to be consistent with our particular worldview, how would we approach this subject matter as someone who believes in like biblical inerrancy, the authority of Scripture, inspiration?
So yeah, I would challenge my secular opponents, or for that matter, my Christian opponents who don't agree with the literal Genesis, that they should embrace the Bible as the Word of God. It is the Word of God. It's what makes science possible. So I think that's something that needs to be challenged. I'm going after the big stuff. I mean, I'm happy to look at details. I can talk about neutrino mass and things like that. I'm happy to talk about that. I'm a scientist, but I would argue it's the biblical worldview that makes science possible in the first place. And so they're stealing from my worldview when they want to talk about scientific evidence. I would argue, no, that's based on biblical creation. You're assuming biblical creationist principles while denying biblical creation. That's inconsistent. That your worldview is wrong. And then if we're going to talk about specific lines of evidence, I'm happy to do that. But then I would use that reductio ad absurdum approach. I would say, well, hypothetically, let's assume your worldview. Let's assume that rates and conditions are constant and that Jupiter, for example, was not supernaturally created, but that it formed billions of years ago. And let's calculate how much energy should be left in its magnetic field or in its internal temperature. And lo and behold, even if we assume your secular assumptions, you get an age that's much less than 4.5 billion years, which is your age for that planet, your assumed age for that planet. Or you can do that with any other planet with other processes. And so what I've shown is that their position as a whole, their assumptions of deep time and uniformitarianism and naturalism are inconsistent. They lead to, in many cases, a much younger universe. Now, in some cases, it's consistent. If you assume radiometric decay rates are constant, so on, then you can kind of argue that the current conditions match that. Okay, but it's not going to explain other things like the internal heat or magnetic fields of planets that you can't line up with your assumptions. So I'm going to challenge their worldview, and one of the ways I'm going to do that is a reductio ad absurdum, by temporarily assuming their worldview, not in reality, but just as a hypothesis to show that it leads to an absurd conclusion and therefore their worldview cannot be true. Very powerful way of arguing. It's the way Jesus argued in his earthly ministry.
Awesome. All right. Let's see. Do YECs think that the laws of physics have changed over time? That is a constant attack against our position. Do they believe
Yeah.
that it's changed over time? Do we have any models to assume that or anything like that?
So I'll give you my take on it because I'm sure there are different young Earth creationists out there. I don't believe that, at least since the fall, I don't believe that laws of nature have changed. And then before the fall, anything's possible before that. We know that things were different before the fall. There was no death of living organisms. Does that mean the laws of nature were different? Not necessarily. It could be. But if they were, it was probably a very, very minor change because everything else we see about before the fall, that we see that the sun's giving light on the earth the way it does now, that means the laws of thermodynamics were in place and so on. So I'll allow that there could have been a very small change of the laws of nature at the time of the curse. We know because God changed the way he upholds creation at the time of the curse. But since then, I haven't seen any evidence of a permanent change in laws of nature. There might be temporary suspensions of laws of nature when God does a miracle. When God, multiplies loaves and fish, he can do that. And that apparently violates the law of conservation of mass. God can do that. He's God. He can do what he wants. When God raised Lazarus from the dead, I have no idea what kind of physical processes were involved in that. Neither does anybody else except for God. God can do what he wants. But aside from these miracles, which by definition are rare, because a miracle is an unusual manifestation and an extraordinary manifestation of God's power, aside from that, I don't believe that laws of nature have changed over time. Now, it's possible, I do think that rates and conditions have changed over time. We have evidence of that. During the worldwide flood, the rate of erosion would have been orders of magnitude greater than it is today. We think that radioactive decay rates were sped up, probably during the flood year, maybe during creation, maybe both. There's evidence of that. Does that mean the laws of physics change? Not necessarily. There are ways to change these things. We can do them in a laboratory. We can't change the laws of physics, but we can speed up certain kinds of radioactive decay, like the rhenium osmium reaction. We can speed that up. God can do it too. So that doesn't necessarily mean laws of nature changed. It just means I do believe circumstances have changed. Whenever God does something very extraordinary and breaks into nature and judges things, that disrupts the normal flow of nature, but not necessarily at the level of physics. So I don't necessarily think laws of physics have changed. I'm open to that because I am a biblical creationist and I know God can do what he wants. But the basic pattern is that the cycles of nature, the day night cycle and seasons, which are based ultimately on laws of physics, God's promised those won't change until the end. They might have changed in a minor sense at the curse, but otherwise God tends to uphold his universe in a consistent fashion, which is what makes science possible. That's a biblical creationist concept. So now other creationists might disagree with me, but that's my take.
Um, I think a lot of creationists would actually agree with you because I don't agree with that the laws of physics have changed and but uh I forgot what I was gonna say something else. All right, but we don't actually our position is that we don't really hold to the what about models and stuff? Do we have any models that assume that? I don't think that we do, because all of our models, even the plate tectonic models, assume because they've actually done computer simulation of the plate tectonics and stuff. Isn't that
Mhm.
right?
Yes, yeah. As far as I know, all the mainstream creation models that are out there, at least all the ones that are more accepted, that have some kind of consensus view, they do not require any kind of change in the laws of nature, laws of physics in particular. Flood models, all the flood models I've seen do not require any change of laws of physics. Some people have said, well, what about the accelerated nuclear decay? Does that involve a change in laws of physics? It could, but it doesn't have to. It doesn't have to. And in any case, you don't. That's just one mechanism God might have used to initiate the flood, but it doesn't require any change of laws of physics. My Starlight model does not require any change in laws of physics. I think Russ Humphreys, I think his model probably doesn't either. Danny Faulkner's might, I don't know. His is a little bit. I'm a little nebulous on the details of his, but in terms of the mainstream creation models, they do not require, in general, they do not require a change in laws of physics or laws of nature.
Um, I have to ask you a question. It's not on my list of questions, but you mentioned the radioactive decay rates and during the flood. Some people, it's one of the popular criticisms that have come up on YouTube is they call the heat problem. Now, the
Mhm.
heat problem is really a generic term for a series of objections, but one particular objection is the idea of that much radiometric decay, decaying to get the amount of 6,000 years worth of decay and generating the flood, and it would create too much heat. It would just melt the earth or make it unlivable, whatever the case may be. And what would be your response to that? Do you see that as a viable objection?
Well, it's something that needs to be considered, but because radioactive decay, when it occurs, it releases energy, and that energy normally goes into the form of heat. It increases the vibration of the molecules, it increases their temperature, and then heat is the flow of that thermal energy from one object to the next. So it should increase the temperature of things. But part of the issue is we don't know what the temperature was before. I mean, the Earth's interior is the Earth has a molten core. It's extremely hot. How do I know that wasn't an icicle before the flood? How do I know the energy didn't go into the Earth? So here's the issue. They're basically saying all that heat would boil the oceans. Well, do the math. Show me how much energy is released, and then what are the possible places it could go? It could go into the Earth's core. It could be released into space. There are ways of dumping energy to space that happens naturally by radiative transfer and then convection in the atmosphere, which then radiates into space. So the only issue is there a problem dumping that energy in a sufficient time? Can you dump it within about a year? All the energy that's created, and given that you can dump some of it in the Earth's core, um, I mean, I think that's something that we need to look into. I think it's something that's worth investigating. But if you ask that as a gotcha question, I don't think it is, because I haven't seen any calculations that show that the energy can't possibly be dissipated in time. We can calculate the amount of we can approximate the amount of energy that's released in radioactive decay. And that's assuming we know the amount of radioactive substances on Earth, which we can kind of estimate, but we don't know it exactly. So we can estimate the amount of energy that's released. But then how do you know that it was trapped in the Earth? How do you know that it wasn't efficiently dissipated to space or into the Earth's core? And I haven't seen a quantitative calculation. So until our opponents, until the critics can make a detailed quantitative calculation, then their objection doesn't have any merit. And so I'm not inclined to. I can't give a quantitative answer until they ask a quantitative question. Let's put it that way.
Right. And I heard you say in an interview one time, suggested, as far as the dispelling the heat into space, you mentioned hurricanes and hypercanes. And I've actually looked that up. Hurricanes do actually, that's one of the ways that the Earth regulates its heat is through hurricanes. And
Yep.
of course, there will be quite a bit, given the global flood. And hypercane is theoretical, but everyone thinks it's possible.
Mhm.
Um, that hypercanes, it's like a super hurricane.
Right.
So, would you say that that would be a good way of dispelling that heat into space?
Yeah, that's one of the ways to do it. That's one of the ways to do it. When a hurricane passes over the ocean, it drops the ocean's temperature by 10 degrees. And that's an enormous amount of energy because water has what we call a high specific heat, which means water can contain an enormous amount of energy. And so when you drop water by 10 degrees, you've dumped an enormous amount of energy. And the hypercane circulates that and eventually it gets radiated into space. So, hypercane would do that. It would just do it on a much greater scale. Hurricanes on Earth. We think there would have been hurricanes during the flood year and possibly hypercanes because there was no land during the flood year. Normally, hurricanes go over land, they get cut off from their power source because land doesn't have the high specific heat of water. But during the flood year, you got water, high specific heat, hurricanes that's going to efficiently dump into the upper atmosphere. There's other ways to do it too. Some of the jets that we think happened as the crust broke apart and so on, those would have vaporized water, shot it up in the atmosphere, falls back as rain. That process circulates. Convection is a very efficient way of getting energy from one place to another. And then eventually it's got to radiate away from the Earth. And again, some of it might have gone into the Earth's core. That's possible as well. So there's different ways to do it. Have I done the quantitative detail? Have I worked out the quantitative math? No. But then again, I haven't seen a critic work out the quantitative math to say it's not possible. So it's something we should look into. I think it's interesting, but it's certainly not. It's not a gotcha. It's not a deal breaker for the rapid plate tectonics.
That's what the critics act like it's a
Yeah.
gotcha. Like, aha, now you
Huh.
can answer that.
Yeah. I mean, if they want to show me the math, fine. But just saying, well, this much energy needs to be released.
Would you say
Okay.
that just kind of just assumes that there's no you in order to argue that you'd have to assume no mechanism for alleviating heat. That
Right.
it's not impossible. It's doable. It just depends on what the conditions were.
Right. What the critic would have to show that all the possible methods by which heat can be dumped are insufficient within a 1 year time scale to dump the energy that's produced by radioactive decay. And again, we don't know how much radioactive decay occurred during the flood year. It might have been a small amount. We don't know because we think that some of that happened during creation week too. So, and I haven't seen that calculation done. So until they do that, it's not an appropriate criticism of accelerated decay.
All right. My next question I want to ask is do the laws of physics, I know we talked a little bit about this, laws of physics require that the universe be old, or do they preclude a young universe? I've heard a lot of old Earth creationists use that argument. I heard Frank Turek use it. I've heard uh, um, uh, actually, I remember what I was going to say before. Frank Turk has a book out called "Stealing from God," and you mentioned that earlier. He's a classical apologist and old earther, but he has a book out called "Stealing from God." I heard it was good. I haven't seen it yet, but that works really well with what we've been saying for a while about how the critics are stealing from us.
Yeah.
But anyway, that's what I was going to bring up before. But I've heard Frank Turk bring this up. I've heard Hugh Ross do it. Uh, does the laws of physics, would the law of physics have anything to do with how old or how young the universe is?
The answer is no, because the laws of physics describe the way that God consistently upholds his universe today. And that has absolutely nothing to do, that by itself has nothing to do with the past, because what God does today and what God did in the past are not necessarily the same. Now, we do know from passages like Genesis 8:22 that since the flood year, God has promised certain cycles in nature will be as they have been before. So God's promised us a certain degree of consistency in how he upholds his universe. But that happened, that promise was made at the end of the flood year. So before that, there was an apparent disruption of the at least the seasons during the flood year. There wouldn't have been a harvest during the flood year, so so there was an interruption at least of what we would think of as cycles of nature. That doesn't necessarily involve a change in the laws of nature, although it doesn't preclude that either. So I would say the way that God upholds the universe today, um, that by itself has no bearing on when God created the universe. And if somebody thinks it does, I would argue that that person has a pretty big misunderstanding about how things work, about what age is. Age is not a substance that you can measure. It's a concept of history, and the way that things happen today doesn't automatically tell you how they happened in the past, unless you're assuming uniformitarianism. And I think folks like Hugh Ross, I know he assumes uniformitarianism, but I think it's so fundamental to his thinking that he doesn't even realize he's assuming it. And so when he's trying to defend it, he assumes it even while trying to defend it. So I think that might be what's going on there. But no, there's nothing in the laws of physics that requires the universe to be old or young. Just based on the laws of physics, God could have created the universe yesterday with all of our memories intact. Now we know he didn't do that on the basis of scripture, on the basis of his revelation, but there's nothing in the laws of physics that says that he had to make it a long time ago or recently. Laws of physics just describe the way he upholds it today.
Right. Now we reached one of my favorite parts of the discussion, making a scientific case for a young universe. But of course, this is going to what we're going to be doing is a reductio ad absurdum argument. So we're not embracing those assumptions. We're not saying those assumptions are okay or biblical or anything like that. What we're saying is that the opposition do assume that, regardless whether we're talking about old Earth creationists, evolutionists, whoever we're talking about, they're assuming uniformitarianism when they make an age argument. And so we're saying, okay, we're going to entertain that argument for a second to show its inconsistency. All right, the first one I got on my list is C14 in diamonds. And if
Yeah,
you want to, you can just kind of, you got my questions in front of you.
I got him. Yep,
If you
thank you.
want, you just go through the list and talk about them if you want.
Okay. Yeah, with C14 and diamonds and fossils and all kinds of stuff, coal deposits and so on. This is really compelling. And I'll grant evidence by itself doesn't prove a young or old universe. It doesn't. But it's very difficult to explain how this could happen if the Earth's billions of years old. Very difficult. And if I were a secular physicist, this would keep me awake at night. The fact that we find C14 in diamonds. The reason why is C14 has a half-life of 5,730 years, and that's the time it takes for half of it to decay into nitrogen. So C14 is constantly transforming into nitrogen. That's decay. That's radioactive decay. And the half-life 5,700 years means that C14 cannot last billions of years. You do the math. If the entire Earth started as nothing but C14, after 1 million years, you'd not have one atom left. After 1 million years, you'd not have one atom of C14 left. And people will say, oh, but it's produced in the upper atmosphere. I know. Cosmic rays bombard nitrogen atoms in the Earth's upper atmosphere, creating free neutrons. And there's a process by which these are converted to C14, but then the C14 constantly decays back into nitrogen. Now, living things on the Earth, they take in that air. Plants take in some of the carbon dioxide in the air. And some of that carbon dioxide, some of the carbon in that, a small fraction of it's C14. Most of it's normal carbon-12, which is stable. There's some C13, which is also stable, and then there's a small fraction of C14, which is unstable. So the plants take that in. We eat the plants, and we use that carbon to build our bodies. So we have C14 in us as well. And it's constantly decaying back into nitrogen. But when you're alive, you're replacing it because you're taking in new C14. You're eating food, which came from plants ultimately. Even when we eat animals, they ate the plants. So either way, we're getting C14 back into our body until you die. And when you die, the C14 simply decays away, and there's no way to replace it. because especially when things get buried. So fossils and things like that are buried deep down in the rays. Cosmic rays rarely penetrate. They can occasionally get down to Earth's surface, but they can't penetrate far into the Earth because they're too high energy. And so stuff that's buried deep down, and if it's been buried for millions of years, there should be exactly 0 C14 atoms left in it. And that's not what we find. Pretty much every fossil we found, if it has sufficient carbon left in it, because the carbon can get replaced, but a lot of times there's carbon left in them, and you'll measure, and sure enough, some of that carbon is C14. And that should not be the case. If the fossil is 100 billion years old, the C14 should be long gone. And the secularists say, well, new C14's gotten in there somehow. But then we found it in diamonds. And diamonds are the hardest substance. These diamonds are supposed to be 1 to 2 billion years old based on other radiometric dating techniques. But they have C14 in them as part of their structure. It's part of the structure of the diamond. And how are you going to get new C14? How are you going to recharge a diamond? How are you going to get new C14 in there? You can't do it. And so C14 is a very compelling evidence that at least the Earth is nowhere near billions of years old. In fact, it's not even 1 million years old, because that C14 should be long gone, and it isn't. You mentioned polonium halos. I'm not going to do a lot with polonium halos because it's something that it's kind of weird. It's something that I don't fully understand, but basically has to do with certain radiation damaging crystals and leaving kind of a spherical ring of damage, because the energy of certain reactions is set, it's fixed. And so that means the energy can travel so far, and you have these little spheres, and when you cut through them, it looks like a sequence of concentric rings. And basically it has to have happened rather quickly, or over millions of years, the structure would fade, because thermal motion will eventually erase those patterns, and yet they're still there. That suggests that a lot of radioactivity has happened in a short period of time. I think there's even better evidence for that than the polonium halos, and that's the next one on the list, which would be helium inside zircon crystals. Helium, one of the products of radioactive decay, certain kinds of radioactive decay, like uranium to lead, produces helium as a byproduct. Every time one uranium lead changes all the way into one uranium atom changes into a lead atom, it creates 8 helium atoms as a byproduct of that radioactive decay. And okay, that's fine. And that's part of where helium comes from, at least. And so that helium, and these were found inside zircon crystals in biotite. And you'd say, okay, but helium is a gas, and gas can leak through rocks, and it should, because rocks are porous, and the gas should leak through the rocks. And the problem is this: we find a lot of helium in these zircons, a lot of helium, which suggests a lot of radioactive decay has happened. And the old earthers says, see, there you go. Millions of years of radioactive decay has happened. But here's the problem. If it happened over millions of years, the helium would have had plenty of time to escape. Helium is a very slippery gas. It's the smallest atom. And so it can, in terms of physical size, and so it can leak through those rocks and escape. It should have plenty of time to diffuse into the atmosphere and be gone. If the rocks are millions of years old, the helium should not be there, but there it is. And the amount of helium that we find is consistent with these rocks being a few thousand years old, but a lot of radioactive decay happening that time. So that's one of the strongest lines of evidence that a lot of radioactive decay has happened in a short period of time, meaning the rates sped up. I find that very compelling. They can't be millions of years old, or the helium would be gone. The erosion of the continents. Did you say something? Oh.
On the helium leaking through the thing, Hugh Ross has this argument. He's used it a lot. He will say if it can slip out, it can slip back in. What would your response be to that?
Oh, that's so silly. Only Hugh Ross would say that. Diffusion goes from the larger concentration to the smaller concentration. You have a lot of helium in these rocks, you have very little in the atmosphere. And so the helium will go out. It will diffuse away from the source. So just to put this in perspective, you know, there's little things they're basically perfume that you plug into the wall, and it makes your house smell nice. I've got those here in my apartment, and it makes it smell nice. And after a while, the volume goes down, and you have to buy new ones. You have to replace it. It would be like Hugh Ross saying, well, what happens is the perfume goes back into the bottle after a while. Well, no, it doesn't. It doesn't. If you leave a bottle of perfume, your room will smell nice after a while, because the perfume goes from the greater concentration to the lesser concentration. That's what makes it work. That's what makes it smell nice. You don't start with a nice smelling room and an empty perfume bottle and expect the perfume to go back into the bottle. That's diffusion doesn't work that way.
Does that fix first law of diffusion? Am I understanding that correctly?
It's relatable to the second law of thermodynamics, but it's not exactly it. It's just a property of diffusion, that diffusion always goes from the greater from a source that has a greater concentration to a sink that has a lesser concentration. And it's something that's statistically provable. You can demonstrate that happens. It's not going to go the other way.
Uh, it wouldn't
Let's
matter
see.
if it did because it would slip out just as fast. So it does make a whole lot of sense anyhow.
Yeah, I mean, statistically, you can have an atom go back in. I get that, but you have a lot of atoms trying to get out, and so that's why diffusion goes from you leave well. Here's the experiment to do: take your bottle of perfume and leave it sit out there, and your room will smell nice after a while, and eventually the perfume will be gone. Now take an empty perfume bottle into a nice smelling room, and if Hugh Ross is right, the perfume will go back into the bottle. But that doesn't happen. That doesn't happen. Diffusion goes in one direction. It goes from the greater source to the lesser. So
Go ahead.
okay, next on your list you have erosion of continents. Yeah, the rate at which continents erode is we can measure that, and I don't have the numbers in front of me, but it's much less than the rate, because people say, well, mountains are being built up. Yeah, but at a rate that's trivial compared to the rate at which continents erode. And if they were really billions of years old, they should be gone by now, and they're not. Or the Earth's gaining salt in its oceans. The rivers of the world pick up a little bit of salt, and even fresh water has a little bit of salt in it, dumps it into the ocean. The water evaporates, it leaves the salt. So oceans actually get a little bit saltier every year. This, by the way, Brian, this was one of the first scientific lines of evidence that I was exposed to that made me realize the Earth has to be the biblical age. It has to be young. Because I remember learning about this. I was in college, hadn't given a whole lot of thought to the age of the Earth, and somebody pointed out, the rate at which salt fills the oceans would be solid salt by now if they were billions of years old. And at that point, I was majoring in physics. I had enough knowledge of math to be able to do the calculation. I checked on it. Sure enough, the oceans can't be anywhere near billions of years old. They could be maybe a million years old, maybe a few million years old, but not billion. They're supposed to be 3 billion years old, according to the secular view. And indeed, they would be solid salt by now, but they're not. And so that suggests that the oceans can't be anywhere near billions of years old. It's consistent with a few thousand years. So, and that's still a good argument.
Right. Some people bring up other processes that can bring salt in there, like plate tectonics and things like that. Did Russell Humphreys actually take that into account, other processes that could bring salt in? I remember him doing like calculating the salt in and calculating the salt out, and
Yeah,
and determining that.
he did. He did. Let's see. I'm trying to remember the numbers. I forget the numbers exactly, but I think the percentage he calculated, because you got the idea to save the secular view, you have to remove the salt somehow. The oceans are saltier than they should be, so you have to remove or rather the oceans should be solid salt if they're billions of years old. They should be pure salt by now. So you have to find a process to get rid of salt. And Humphreys included plate tectonics, and he included salt sprays. Salt sprays would be a way to get rid of some of the salt. And he calculated that at a maximum that could get rid of, I think it's 27% is the number. So that doesn't make a dent. And I think it's 400 million tons of salt that are dumped into the ocean every year, if memory serves, something like that. So yes, he did include inputs and outputs, and you do have to do that. You do
This
have to do that.
also this also shows a difference between our assumptions and their assumptions, because in ours, if a global flood occurred, that would actually deposit a ton of salt into the ocean.
It
But
would. Yeah.
but in order to assume to show that their argument leads to an inconsistent conclusion, if you just say, okay, let's take out the global flood, you still
Right.
won't get billions of years worth of history for the oceans.
Right, exactly. And that's what Russ Humphreys did. He did a proper reductio ad absurdum. So he assumed their assumptions, and he was even generous to the critics. He made the influx of salt the smallest of their possible estimates, which would make the oceans as old as they possibly could be. And he still computed a maximum age of, I think the number is 62 million years, maximum age, but it's supposed to be 3 billion years old. So you see, it's inconsistent with their assumptions. And so it's a proper reductio ad absurdum and a very compelling one.
I remember he.
Another example would be the decay of Earth's magnetic field. We can measure that decay. We'd expect it to be decaying because magnetic fields are caused by electrical current in Earth's core. That current runs down with time just due to electrical resistance. The Earth is not a perfect superconductor, so the magnetic field will decay with time. All magnetic fields do. And if you calculate the rate, and this was first done, I think, by Thomas Barnes, but it's been verified by other people as well, including myself. I did this calculation a while back and concluded that the Earth's magnetic field would have been about 20 times stronger at creation 6,000 years ago. But if you run it back even 60,000 years, if you run it back 60,000 years, because it's an exponential decay, which is what we'd expect it to be on the basis of first principles of physics. If you run back 60,000 years, the magnetic field would be stronger than that of a neutron star, which is enough to rip the atoms of your body apart. So it can't be anywhere near even 1 million years old. So that's a very tight constraint. The Earth's magnetic field is a very tight constraint on the age of the Earth. And it's not just the Earth. Some of the other planets of the solar system, not all of them, but some of them have powerful magnetic fields that can't last billions of years. Jupiter, incredibly powerful magnetic field, and it should basically be much weaker, if not gone, if it were really 4.5 billion years old, the secular age of the solar system. Uranus and Neptune, secularists were not expecting, at least with Uranus, they were not expecting it to have a magnetic field at all. And Russ Humphreys predicted the magnetic field of Uranus based on its biblical age of 6,000 years. He's got a model for how God might have started the initial strengths of the magnetic fields. It's a neat model. And he's able to estimate the magnetic strength of any object in our solar system with pretty good accuracy. And he predicted back in, I think it was in 84, he predicted the magnetic field of Uranus and Neptune. And then in 86, Voyager 2 flew past Uranus and measured its magnetic field, and it was consistent with Humphrey's prediction. And then in 89, it flew past Neptune and likewise confirmed Humphrey's prediction for those. So that's an example of really good science. I've always been impressed with Humphrey's magnetic model for the solar system.
A lot of people often accuse young Earth creationists of not being able to make predictive predictions based on their models, and that's just not true. We actually can make predictions based on our models. And so I think it's just kind of like an agenda to try to make us unscientific and that sort of thing. Like they'll say things like, "Oh, y'all don't publish in peer review." I had someone tell me that the other day. I said, "Yeah, we do."
Yeah.
But on the subject matter of the EM fields, I was kind of waiting for you to talk about the planets too. And I
Mhm.
know that Neptune, Uranus, they have strong magnetic fields. I think I've heard that there's evidence that the moon used to have one, but doesn't have one now
Correct.
because uh,
Correct.
I forgot what it was, but certain conditions would decay the magnetic field real fast. But what about dynamo theories? That is a very popular view that they bring up often to try to explain why we still have magnetic fields. And of course, dynamo theory actually gets even worse though with the planets. But we'll get into that. But describe some of the problems with that view because I know that's a very common objection to the planets having EM fields.
Right. First of all, it's an admission that this is a problem in the secular view because the secularists can do the same math I can do. They know that the magnetic fields at their current rates of decay would not last anywhere near even 1 million years. For the Earth, it's like 60,000 years, something like that. So what they've said is there must be a recharging mechanism to build up the magnetic field over time. And they think that's what's responsible for the oscillations. There's evidence that the Earth's magnetic field flipped in the past. We think that's related to the flood, and it's the flood that did that. So we don't think it'll flip again. But the secularists say, well, there's this process that recharges the magnetic field somehow using Earth's rotational motion. And it's supposed to be a bit like the alternator in your car if you have a gas vehicle that takes the motion of the motor and uses that to recharge the battery. So the idea is you can take the rotation of the Earth and use that to recharge the magnetic field. But there's a problem with that. There's something like that going on in the sun, but there's no evidence that the sun's magnetic field is being recharged that way. But the sun's magnetic field does flip every 11 years. And we think that's related to the fact that the sun rotates differentially, meaning the equator, the sun's a ball of gas, and so it doesn't rotate like a solid. The equator rotates faster than the poles. So the sun's twisting itself up constantly, and we think that's responsible for the magnetic interaction that takes place on the sun. The assumption is that recharges the magnetic field. That's never been proved. But one of the problems is Earth does not rotate differentially. So I don't know how they can try to. I don't even know how they can possibly propose a dynamo model for the Earth, because the Earth rotates more or less like a solid, because it is kind of solid. I mean, the part of the core is liquid, but the crust is solid. Most of the mantle is solid, and so and it doesn't rotate differentially. The equator rotates at the same rate as the poles. They both have 24-hour days, 30 or 23-hour, 56-minute sidereal days. So that's one problem, is the dynamo doesn't even seem to be theoretically possible for a planet like the Earth, a terrestrial planet. Secondly, it's never been proved that that actually recharges the magnetic field. And third, I'll leave the third is the quantitative details of it are basically a dynamo leaks. It doesn't preserve the magnetic field. And Russ Humphreys has done some quantitative calculations on that. So I'll defer to his expertise in that particular area.
There's
But one, and then
I was
go
gonna
ahead.
say there was one thing I heard about the like the in case of the Neptune and Uranus, the
Yep.
magnetic fields are actually they're off.
They're tilted, right? And the dynamo model doesn't predict that. The dynamo model predicts that the magnetic field should line up with the rotate. It has to line up with the rotation axis to get it to work. And when Uranus's magnetic field was measured by the Voyager spacecraft and was found to be tilted relative to the rotation axis by an enormous amount, they thought that can't work. And I thought, well, maybe it's in the process of flipping. But then it went past Neptune, and Neptune's was also tilted enormously compared to the rotation axis. And so they figured that's probably not the best explanation, because the odds of both of them flipping at the same time would be pretty astronomical. So yeah, so that is one of the problems with the dynamo model, is it requires the magnetic field to be aligned with the polar axis. Now with Earth, it's not too far off, although it's not exact with the Earth. But with the Uranus and Neptune is way off. So that's an additional problem with the dynamo model, in addition to the quantitative details and the fact that that a dynamo has never been demonstrated to be able to recharge a magnetic field. There's evidence that it actually makes it decay faster. So and then again, Russ Humphreys has done some of the work on that.
Does Venus have a magnetic field?
I don't think Venus. I could be mistaken. I don't think Venus has a magnetic field.
That's why I
I
heard
could be mistaken.
that it didn't have a because I know that I heard that they thought the Venus's core was solid because of how dense the planet is, and I looked it up to try to see if it had a magnetic field, and internet says I don't know if it's true, but what I understand from the internet, it doesn't have a magnetic field.
I don't think it does. Now Mercury does. Mercury does. Mars has remnant magnetism, but it doesn't have a global magnetic field. And the moon has remnant magnetism. And that's what you were thinking of earlier. Remnant magnetism is an indication that something once had a dipole magnetic field, but no longer does. So even in 6,000 years, they've run out because they're small.
All right, you can go ahead. I just wanted
Okay.
to clarify that.
Lunar recession. I think this is pretty compelling. The fact that the moon is moving away from the Earth due to tidal forces. The moon causes tidal bulges on the Earth, but because the Earth rotates faster than the moon orbits, the tidal bulges get ahead of the moon. They pull forward on it. And when you pull forward on something in orbit, it moves out. A little counterintuitive. But when the astronauts want to go into a higher orbit, they thrust forward and moves them out. And so, and today we can measure the rate at which the moon's drifting away from the Earth. We can bounce a laser off of it. And by timing the laser, we can get the distance, because that's a round trip. So we can do that. And we know that the moon is moving away at about 1.5 inches a year. So it's not a huge rate. You run it back in time, 6,000 years ago, the moon would have been 750 feet closer to the Earth. Not a big deal, less than a mile difference. But if you run it back billions of years, the problem gets a little more complicated, because if the moon's closer to the Earth, the tidal bulges would be bigger and the rate would have been faster. So you have to use calculus to account for the gradually changing rate. And that is the assumption of the uniformitarianism, is that the rate changes, but it does so gradually. It's not a catastrophe. And so you include that, and you find that the Earth and the moon would have been touching. They'd have been in the same place 1.45 billion years in a hypothetical past. But the problem is the Earth and moon are supposed to be 4.5 billion years old. They're supposed to be much older than that. So the recession of the moon puts a huge constraint on the age of the Earth-moon system that's much less than is required in the secular view. Because even those who believe that the moon formed when something collided with the Earth, they think that happened close to 4.5 billion years ago, because there's
Right.
already life on the Earth 3 billion years ago, and so on.
The moon argument is actually one of my favorite ones because it's an example where you can't arbitrarily assume that the rates of the condition, and that sort of thing. And funny thing is, I've actually seen seen old earthers actually abandon their uniformitarian assumptions and maybe assume it's at a different rate.
Yeah.
So I've
Yep.
actually seen them do that before. One common argument that I've heard from Hugh Ross, and Hugh Ross is the only one I've ever heard use this argument. I haven't ever heard anyone else use it, but he would claim that because the moon is tidal locked. Now, you can go on NASA's website and they'll actually admit that the moon's leaving us. I mean, you can find entire articles on this. But tidal locking is just the way in like the moon and the Earth's orbit are aligned, and it's the reason why we always see the same face of the moon. Would that prevent the moon from leaving us? That's the implication is that it would keep it from happening.
Yeah, you know, I ran through the numbers on that, and it has almost no effect. The rotation of the Earth. I'm assuming that Hugh Ross thinks that in the past the moon would have been rotating, which in a secular view it could have been, and then as it became tidally locked, some of the energy went into that, but the energy is orders of magnitude less than the energy that's involved in the moon's orbital motion around the Earth. So it's negligible. So that's not going to make a difference. The arguments I have heard that have tried to salvage this, some have said an orbital resonance, and maybe that's what Hugh Ross meant. Maybe he meant resonance, could lock the moon in. But I don't know how you get a resonance. I don't know how that would work physically. When two things are in orbital resonance, that can create a stable condition. Like 3 of the 4 of Jovian moons, of the Galilean moons, are in an orbital resonance, and that seems to be very stable. Resonance is where the period of one is like twice the period of the other exactly. So it's like a 2-to-1 or 3-to-1 or 4-to-1 ratio, or 3-to-2, something like that. And those can create stabilities, but they can also create instabilities. That's why you don't have asteroids in certain places, in certain locations relative to the orbit of Jupiter. You got these gaps in the asteroid belt. But anyway, so I don't think that's going to work with a rotation though, because the Earth is a rotating mass. And so to argue that there's some kind of resonance between the moon and the Earth, and that's going to affect the speed, I don't see that happening. And in any case, I haven't seen secularists really, I haven't seen them jump on that argument as a good solution.
Right.
I have heard some that have argued that the different distribution of the continents in the past would affect that. But as far as I can tell, first of all, there's been a simulation where they found that didn't have a strong effect, where they simulated the effect of a continent on the pole versus a continent on the equator. It didn't have a huge effect on lunar recession. And secondly, I would think it would work in the wrong direction. Having a supercontinent would allow the tides to build up more, which would make tidal recession faster, not slower. So I think it actually works in the wrong direction to make that, to solve that problem. So I don't think it's a good solution for them.
Right. My understanding though, also it would actually cause problems between if the moon was too close to the Earth. The moon is
Yeah,
what the gravity of the moon is what controls our tides.
right.
And I've heard that the tidal forces alone would rip the moon apart. Is that true?
Yeah, once it gets within a certain distance, yeah. And it would be within, there's the Roche limit. The Roche limit is if you had like a pile of debris, beyond the Roche limit, it's the gravity would hold the debris together. Inside the Roche limit, the debris would separate. Now the moon has some internal cohesion due to chemistry, so it could go a little bit inside the Roche limit. But if you get too much inside that, then the tidal forces would shear the moon apart. So yeah, so the 1.45 billion years takes them all the way back to the same place. That's an extreme upper limit. So before that would happen, the Earth would shred the moon anyway. So yeah, so that is an upper limit. The true maximum age is going to be less than that.
And if you jump it off from safe distance, then after billions of years, we wouldn't even have a moon. It'd already be gone.
It would be, yeah, actually what would happen, it would move out to a maximum distance where it would slow the Earth's rotation to where they would both be tidally locked. So it turns out the moon wouldn't escape completely, but it would be very far away, and the Earth would be tidally locked with the moon, so that they each keep their same face pointed at each other. So
So it'd
that's
be
what would
like
happen,
a
and
really,
we're
really
not in
big
that
orbit.
condition. What's that?
I said it's like a really, really big orbit
Yeah,
of the
yeah.
moon.
The month and the day would then match. It would be, yeah, it would be a very far orbit. So yeah, so I think the lunar recession argument's pretty solid. I think it's one of the better lines of evidence. There's not too many realistic rescuing devices you can account for to explain that away. We have comets. Comets are made up of ice and dirt. They orbit the sun in elliptical paths. When they come close to the sun, that icy material gets vaporized and blasted into space, which is what forms a comet's tail. And so every time you see a comet, it's getting smaller. I've seen many. I've seen comet. I used the SOHO spacecraft in my doctoral dissertation, and it's really good at spotting comets when they get close to the sun. It's hard for us to see them, but because they're close to the sun, it's day out. But SOHO is designed to look at the sun, and it's got an instrument that blocks the sun and looks at comets as they get really close. And then and I've seen comets that have disintegrated in one path. I've seen comets that do not exist anymore. So they don't last. They don't last millions of years. They can last 100,000 years maybe, but they don't last millions of years. And of course, the rescuing device there is we've got a comet generator that makes new ones. That's the Oort cloud, and to some extent the Kuiper belt. But most secularists believe that the Kuiper belt needs to be recharged by the Oort cloud anyway. So in any case, there's no evidence of that. There's no evidence of this potential reservoir of trillions of potential comets. So it's just a rescuing device. Comets seem to be just good evidence of a young solar system. We've got the faint young sun paradox, which is acknowledged even in the secular literature, the fact that everything we understand about nuclear fusion, how it's taking place in the core of the sun, I think there's good evidence that that's happening. But as that process happens, helium accumulates in the core of the sun, and I won't go into all the details on what that does, but one of the things it does is it causes the sun to basically causes the fusion to have to heat up in order to compensate for the fact there's less hydrogen. It's kind of counterintuitive, but basically the sun should become brighter over time, which means 4.5 billion years ago, it should have been much fainter than it is today. It's 30 to 40% fainter, depending on exactly what time you put that. And yet 3 billion years ago is when life's supposed to be forming on the Earth. But wait a minute, the sun's 25% fainter, even 3 billion years ago. The Earth should be a frozen ice ball. You're not going to have life developing on a planet that's frozen solid. You don't have liquid water, you're not going to have life. So that's a problem. That's the faint young sun paradox. The fact that when you run the equations backwards, the sun should have been fainter in the past
Can I
as
ask you a
it's
question
getting.
real quick?
Go ahead.
Um, I've heard that there are limitations on fusion. I heard that you can't fuse past iron. I've heard that other people say that the conditions inside the star may be able to allow fusion past iron. And I've heard there's one argument I've always wanted to sit there and find out if it's true or not. It's interesting, but it's the only place I've ever seen it. They call it what was it? The gap for helium 4 or something like that, where you can't skip past or can't fuse past a certain point in helium or something like that. I don't know if you've heard of that. I can't remember the
Okay.
exact name of it.
There is a gap. Let's see, there's hydrogen, helium, lithium. Lithium. Once you get there's a gap between lithium and beryllium. So that might be what you're thinking of. But back to your other question, that one I can answer. It turns out that the hydrogen is kind of the easiest gas to get to fuse. It would really rather be helium. And so if you can heat the energy enough, if you can heat it up to we think the core of the sun's about 15 million degrees Celsius, something like that. And if you can heat up hydrogen gas of that density, it will atom by atom. It's kind of a slow process, but it'll eventually convert that hydrogen into helium, and that releases energy. But the temperature is not hot enough to slam helium atoms together to get something better, or even hydrogen into helium to build up, larger elements. So you need much higher temperatures to do that. And that's not thought to take place in the sun. So hydrogen to helium is the only nuclear reaction that's happening with the sun in any substantial proportions. Now, in stars that are bigger than the sun, that are more massive, the temperature can be hotter, and you can get what's called the CNO cycle, where carbon, nitrogen, and oxygen, because there's small amounts of carbon, nitrogen, oxygen in the sun as well. And in larger stars than that, basically they act like a catalyst. They can help hydrogen fusion to take place more efficiently, but those three elements are not ultimately used up in the reaction. They just help. That's called the CNO cycle. And there's maybe a little bit of that going on in the sun, but not very much. The sun's primarily what's called the proton-proton chain, which basically you're slamming hydrogen atoms together and eventually getting helium, and then helium-3, and then eventually helium-4, and the process is complicated. But that's really the only significant fusion that's going on in normal sun-like stars is hydrogen into helium. And then it's thought that in stars that are in the giant stage, which in the secular view, they've already done the proton-proton chain and they've run out of hydrogen in the core. Now, we don't really know that this is happening, but theoretically, the star could collapse in on itself a bit, which would raise the temperature of the core. You press in on it, raises the temperature, then eventually you can get helium to fuse. And then for stars, the mass of the sun, it's thought that once they run out of helium, that's kind of it. They collapse on themselves and become a white dwarf. But for stars that are much more massive than the sun, the process can continue to where it collapses in again, and then the helium fuses, and then the next element, and then the next element, and then the next element, all the way out to iron. And then once you get to iron, the problem with fusing iron is it doesn't release energy. When you slam iron into iron, it'll make a heavier element. It actually takes energy, it absorbs energy. And so that's why you can't power a star that way. And so it is thought, however, that during a supernova, the conditions are so intense, the energy in the core is so enormous because the star is collapsing in on itself, that you will temporarily get iron fusion. And that's supposed to be what produces the heavier elements. And I think that's plausible. I just don't think all the elements were produced that way because the Earth was made before the stars and it has heavier elements. So I know not all the heavy elements were made that way. So that's kind of how that works. But ordinary stars like the sun, they're only fusing hydrogen. That's it. They don't, and then if they become a red giant, maybe they can fuse helium for a while, and then that's it. It's the really heavy stars that can fuse heavier elements only up to iron, and then they explode because they can't. The fusion of iron does not release energy. Any elements heavier than iron, you fuse them, it takes energy rather than releasing it. So that's where that's coming from.
I'm sorry, I know that's a little off topic, but I
Okay.
was always curious about that. And I never asked you that question before when we did the origin of the universe. Go ahead.
Okay. And next on your list, you got the planets losing heat faster than they take it in from the sun. And 3 planets in the well, actually, several planets do that. The Earth does that too. But with the Earth, the difference can be accounted for perhaps by radioactive decay. The idea is the Earth has radioactive elements. They produce heat. So that's why the Earth can release a little bit more energy than it gets from the sun. But the outer planets, Jupiter, Saturn, and Neptune, Uranus is the exception. Jupiter, Saturn, and Neptune give off more energy than they get from the sun. And you can't account for that by radioactive decay because they don't have radioactive elements, at least not in any substantial supply. Radioactive elements are heavy, they're dense, and like uranium, stuff like that, very heavy. Jupiter's primarily hydrogen and helium, so it doesn't have a lot of these radioactive elements. And yet it's giving off more than twice as much energy as it gets from the sun. 2.18 is the latest number, I believe, 2.18 times as much. So every second of every day, it's taking in 1 unit of energy from the sun and giving away 2. It's constantly losing energy. And if it were billions of years old, it should be an icicle by now. It should have lost all that internal heat. That's called internal heat. Jupiter has it, Saturn has it, Neptune has it. Uranus doesn't. Uranus takes in exactly the same amount as it releases into space. So it's already cold. But 3 of the planets defy that. With Saturn, they think they have an explanation for it. They think that helium sinking into the core releases gravitational energy, and that's possible. So I don't use Saturn as the example, but with Jupiter and Neptune, there's no good mechanism that can explain why they're allegedly, after billions of years, they're still releasing heat out into space. The analogy would be like taking a potato out of a microwave. You just nuked it. You can feel the heat coming off of it. It's nice and warm. But if you came back 2 hours later, you would not feel the heat coming off of it anymore because it would have radiated that heat into space. Now, Jupiter and Neptune, they're much bigger potatoes. They can do that for thousands of years, but they can't do it for billions of years. So the internal heat of Jupiter and Neptune particularly, maybe Saturn, but again, there's a possible mechanism with Saturn and also with the Earth. Go
Can't
ahead.
spend more. Well, I was gonna say you can't spend more than you take in unless you're the federal government, right?
I should the federal government. That's right. That's right. I do that
They
sometimes.
can't do that forever. Um,
Right.
but I do want to ask you about. I did hear someone try to raise this objection before. Like we don't know that much about the internal heat. I think or internal temperatures. I think she was saying that about Jupiter. How would you respond to that? Is that like a fallacy in logic? Like we don't know that much about it, therefore, you know, maybe I don't know how what their thinking process was on that, but how would you respond to someone who just kind of just says, nope, we don't know that much about their internal workings.
I would say that's a fallacy of a relevant thesis because we don't have to know a lot of the details of what's going on in the core of Jupiter, for example, to calculate the amount of energy that's being radiated away. We know we've had spacecraft orbiting Jupiter. Galileo spacecraft orbited Jupiter for years, and it measured. And we have other instruments. We've had other spacecraft that have passed Jupiter and have measured the energy coming away from it. And so that tells us what the internal temperature is. There's what's called the heat equation, which is widely used in physics, that tells you how heat flows on the basis of temperature difference between a source and a sink. And so this is very straightforward physics. It's not complicated. It's something you'd learn in a freshman level physics class in college, maybe even in high school. But we can calculate the amount of energy that Jupiter's releasing. We can calculate the amount of energy that Jupiter could maximally contain, because we know how big the planet is. We know what it's made of from spectroscopy and from its mass, because we have moons orbiting it. So we know its mass. We know it's hydrogen, helium. So we know the specific heat of those elements. There's a few. I mean, there's a little bit of ammonia and methane, which is what makes the clouds colorful. But we can calculate that stuff, and that's not. That's not an issue. Jupiter simply should not be as warm as it is if it were billions of years old, and it's a legitimate problem. In fact, my somewhere back on that shelf, my the introductory textbook I used when I was in college admits that. It's a secular textbook, but it admits that that's a problem with Jupiter, and I commend the author for being honest about that. So it is a real issue.
Right. And the next one is going to be one of my favorite ones that you bring up personally. I've seen you bring up.
Yeah, you've got the existence of blue stars, which I think is very compelling, because no one doubts that blue stars cannot last billions of years. They can't. And we know that because we can calculate the amount of energy available to them. We know how much hydrogen's there. We know their mass. We can estimate that. And we know the rate at which it's being released, because we know how bright they are. And so we can divide, and that gives you a maximum lifespan of blue stars on the order of a few million years, perhaps. They're the hottest, bluest. It depends on how hot and blue it is. The hotter the bluer, the shorter the lifespan, because they radiate more energy into space. No one denies blue stars cannot last billions of years, and yet they're everywhere. We find them in the universe. We find, especially in spiral galaxies. Spiral galaxies, especially in the disk, have lots of blue stars in them. You can go outside tonight if it's a clear night and look up. You'll see blue stars everywhere. You'll see. It's even better in the winter when you have Orion, because the three stars in Orion's belt, those are nice blue stars, and those can't last many millions of years because they don't have sufficient fuel, and yet we find blue stars everywhere. And the way the seculars try to come back from this is they'll say, well, blue stars have formed recently. And if you've ever heard of a star forming region, let me clue you in. We do not see stars forming in so-called star forming regions. Star forming regions are regions of space that have lots of blue stars. And the secularists know that they can't last billions of years. So the assumption is they must have formed recently in a universe that's otherwise old.
You said that's circle.
But yeah, I think there's a little bit of circular reasoning there, because the assumption is that, well, since we know the universe is billions of years old, and yet we know these stars can't last billions of years, they must have formed recently in an otherwise old universe. But star formation itself is very problematic. And I've never dogmatically said stars can't form, but I'm very skeptical of star formation, because gas does not normally just compress in on itself and form a little sphere. It doesn't do that. Gas tends to spread out, especially in space where there's no container. It spreads out indefinitely. Nebulae in space tend to expand. There's a theoretical mass that they could have, the Jeans mass, a theoretical density where the force of gravity overcomes gravity is an inward force, gas pressure is an outward force. Theoretically, gravity could overcome gas pressure, but I'm not aware of any region in space where that's actually happening. Normally in a nebula, the outward force of gas pressure is orders of magnitude greater than the meager inward force of gravity. So nebulas are not just going to collapse in on themselves and form a star. So that's the problem with blue stars. It's not that the blue stars by themselves prove a young universe, but the fact that there's no really good mechanism to get a star to form, and the fact that we find blue stars suggests that the entire universe is thousands of years old, nowhere near billions of years old. And so blue stars are pretty compelling.
There's something I want to make sure everyone is clear on, that we're not saying that they're actually a couple million years old, or red stars are billions of years old. We're saying potentially they can last that long.
Right,
Of
exactly.
course, and blue stars are young stars relative to even older positions as well.
Yeah, yeah. The secularists would say the maximum lifespan of a star is determined by its mass, and the blue stars are the most massive. And it's inversely related. So the more massive a star is, you'd think it would last longer. It's got a bigger gas tank. Yes, but it gets poor gas mileage. So blue stars are like the SUV of the star world. They got a big gas tank, but they got poor gas mileage. They only get a few miles per gallon, and so they don't last millions of years. The red stars, theoretically, the smallest red stars theoretically could last longer than the secular age of the universe, billions of years. So they're not a problem per se. It's the blue stars that are a problem because they can't last billions of years, or even a few million, the hottest ones. So I think that's pretty compelling. And then we got the wind up problem, the spiral galaxy wind up problem. This was neat. I studied this in grad school, which I thought was interesting. Spiral galaxies, not all galaxies are spirals, but a lot of them are. Maybe 40%, something like that. So the inner portions rotate faster than the outer portions. The inner portions are doing this, the outer portions are doing that. And if you think about what that does to that spiral structure, the spiral structure would have to get tighter and tighter. It increasingly twisted. And I've even run computer simulations using the actual measured velocities of these stars that we've measured from their Doppler shifts, and then sped them up over time to see how long does it take for that spiral to be twisted beyond recognition. It doesn't take more than 100 million years. It's really tightly wrapped. By the time you get out to a billion years, you can't see distinct spiral arms anymore. They're just all blended together. And yet, most secular astronomers believe that the majority of galaxies, spiral galaxies, are 10 billion years old. That's a typical age of a spiral galaxy. But they wouldn't be spirals anymore. They'd be uniform disks. And we don't really see that. We don't see spiral galaxies that are really tightly wrapped as if they had been wrapping themselves up for billions of years. We just don't see that. So I think that's pretty compelling. And it's something that secularists are aware of this. It's called the spiral wrap up problem or the spiral winding problem. And it's something we studied in grad school. We studied possible solutions to it. One solution that was popular when I was in grad school was called the spiral density wave hypothesis, which basically says there's these density waves that for some reason travel through the galaxy and compress the material, and that generates new star formation. So the idea, again, is as old spiral arms wrap themselves up, new spiral arms form to replace them. And that's pretty neat, but it assumes star formation. And I've already given my opinion of star formation as unlikely at best, or perhaps very rare. So I think that's not a very good rescuing device for the spiral winding problem.
The next one is pertaining to how we are seeing the galaxies far away. They look very closely
Okay.
like the ones like near us. They
Gotcha.
don't look
Yes.
like, I mean, of course, they don't. I mean, we don't know what it looks like per se, directly, but we understand that it looks basically like what we see close up. And the secularists predicted that what we would see is the galaxies in their early stages of formation. And spiral galaxies, if I'm not mistaken, spiral galaxies are considered relatively young galaxies in the old paradigm, isn't it?
Well, yeah, the assumption was that the first galaxies should be sort of irregular and clumpy and very low mass. And then the idea is as galaxies interact with each other, some of them become elliptical, some of them become spirals. And that's supposed to take time. And so this isn't so much an argument for a young universe as it is that the Big Bang or the secular view of galaxy formation and evolution is wrong. And it is. Because the expectation was with the James Webb Space Telescope, as it looks to the farthest galaxies, and being far away in the secular view, their light should have taken billions of years to get from there to here. So we should be seeing not these galaxies as they are, but as they were shortly after the universe formed. The farthest galaxies should be babies. And I don't accept that view. And so I predicted that the farthest galaxies should be very similar to nearby galaxies. We should see lots of spirals. They should be high mass and so on, fully formed. And that's exactly what we found. The baby galaxies that the secularists were looking for in the James Webb Space Telescope data, they're not there. The galaxies that we do find, we find spiral galaxies. I wrote an article, oh, I don't know, a while back, based on the discovery of what appear to be barred spiral galaxies. And barred spiral galaxies are supposed to take several billion years to form, and yet we find them within the first, billion years after allegedly the Big Bang, based on their distance in James Webb Space Telescope data. So the fact that a barred spiral is where the center of the spiral is kind of a straight line, and then it starts spiraling out. They're beautiful. And about 50% of galaxies are barred spirals, maybe even more. And we're now seeing these at incredible distances where they were not supposed to have formed yet. So the fact that the most distant galaxies are very similar to nearby galaxies, that's a prediction of biblical creation, because we don't believe we're looking back in time. I don't believe that galaxies have evolved over billions of years. And so I believe that the galaxies out there ought to resemble galaxies nearby, same creator. And so I'd expect the same approximate size range, the same mass range, similar luminosities, similar structure, similar morphology, and similar metallicity, meaning the percentage of heavy elements ought to be comparable to nearby galaxies. It wouldn't have to be exactly the same. And that's what we're seeing. And I actually made these predictions back in January of 2022, before the James Webb Space Telescope had observed these galaxies and released the data. We didn't get our first data set until July of that year. So 6 months later. And then the predictions that I had made in terms of galaxies farther away than they were expecting, galaxies fully formed, massive, and galaxies with metallicity, all confirmed. The Big Bang expectations were totally wrong. And so that's something that I've written up on the website, biblicalscienceinstitute.com, if you want to read that. I think James Webb Space Telescope confirms creation cosmology, or something like that is the title of the article. And since then, we've been able to make even more discoveries with these James Webb Space Telescope data that suggests that the way the universe is expanding is very different from what the Big Bang requires. The Big Bang requires the fabric of space expands along with the galaxies, and the latest observations show that it doesn't. And so I've got a new model out there called the Doppler model that explains how the universe is expanding, why it's expanding, that makes quantitative predictions about what the James Webb Space Telescope will discover next. And in particular, I'm predicting that as the James Webb Space Telescope detects galaxies at farther and farther distances, their average angular diameter, or median angular diameter, ought to be around 0.2 arc seconds. And that's 10 times smaller than what the Big Bang requires. So we'll see if that's right. But there's another example of a quantitative prediction based on biblical creation. And in a few years, we'll know if I'm right about that.
Right. Of course, this does not sit home very well with skeptics. Have you heard critics trying to respond to it like, no, you're misunderstanding the James Webb Telescope data and things like that? Have you encountered those kinds of objections?
Yeah, I mean, with every one of these arguments that I presented, there's always objections. Now, with the James Webb stuff, there haven't been too many, because the fact is they can wave their hands and dance around all they want to, but the fact is I made successful predictions. They didn't. The James Webb Space Telescope, the galaxies that it's seeing are what I predicted as under biblical creationist assumptions. They are not what the secularists predicted based on their assumptions. My new prediction based on the sizes of these galaxies, the angular size, suggests that the universe is not expanding according to the Friedmann-Lemaitre-Robertson-Walker metric, but even though the galaxies are moving away from each other, the universe is expanding in that sense. But that makes a specific quantitative prediction. There's always rescuing devices, and if you'd like, we can talk about some of these for the various lines of evidence, like the carbon dating, the C14. The fact that we find C14 in diamonds. Usually, the secularists have one of two explanations for that, because remember, C14 doesn't last millions of years. Yet we find it in diamonds that are supposedly 1 to 2 billion years old. It should be gone if they were 1 to 2 billion years old. So usually the secularists either say, well, there's contamination. So somehow new C14 has been added. They might say on the surface, but the fact is that's not possible, because when these diamonds were tested for C14, they use acid to dissolve away anything on the surface. And then they had to destroy the diamonds to carbon date them, unfortunately. So you have to destroy the diamond to do that. But they know, these labs know what they're doing. They know how to get rid of surface contamination. They use acid to do that. So that's not going to be an issue. Yeah, so the other explanation is that the C14 has somehow been recharged by other radioactive decay, because there's other radioactive elements deep down in the Earth. Cosmic rays can't get down there. So that's not going to work. But they've said, well, there's other radioactive decay that releases energy that could recharge the diamonds. That doesn't work. And it doesn't work because there's not enough of it. The rate team investigated this issue and found that you'd need at least, I think the number was 13,000 times more radioactive elements for that to be a feasible mechanism. And let me see if I can explain why this doesn't work. You can think of carbon decay, C14 decay. Imagine you have a milk jug and you cut a hole in it about an inch in diameter. The milk is going to gush out that hole. Okay, that's C14 decaying. It decays fast. These other mechanisms, it's like a gallon of milk, but you take a pin and you poke a little hole in it, and a little bit of milk trickles out, maybe drop by drop, just drips out. Okay, that's like uranium changing into lead. That's a very slow process. Now imagine that you dug up a milk bottle and it's gushing out milk. Your natural inclination would be, wow, somebody must have just buried, this is recent, because the milk would be gone. If this was buried days ago, the milk would be gone by now because it's gushing out. And in fact, a few minutes, it's all going to be gone. So what the secularists have basically said is, well, these other milk gallons that are dripping out like that, they've recharged it. Well, think about that. Think about taking a milk gallon that's just dripping a little bit at a time and using that to fill up one that's gushing out. That's not going to work, is it? Because the rate at which this happens is so small, it can't compensate for the enormous amount of milk that's gushing out of that. And so using these other radiometric decay processes to recharge carbon isn't going to work because they're much slower than the carbon process. Now, the way you could do that is you could say, oh, but there's not just 1 gallon of milk dripping. We've got thousands of them. Then it would work, but you'd need to multiply the rate difference, the rate ratio, by the ratio of heavy elements to C14, and that doesn't work. You need like 13,000 times more radioactive elements, so that is not going to work. So anybody who argues that the C14 is being recharged by other radioactive decay hasn't done the math.
Right.
We have.
Are there any evidences, biblical or scientific, that old earthers, like old earth creationists, point to claim the idea that the universe must be a billion years old? Things like ice core. I know that older Hugh Ross has tried to argue some stuff on Yom and things like that. Obviously, we won't be able to have time to go into as many details that I would take an entirely another video. But could you give maybe some examples and some responses?
Yeah, sure. For the Earth, the big one is radioactive decay. That is far and away the most common belief among secularists. The most common evidence that is used to allegedly prove billions of years is the rate at which these heavier elements like uranium decays into lead. They don't use carbon dating because they get the wrong answer. With carbon dating, the Earth's young. There's no doubt about that. But with these other methods, you can get billions of years. But what are they assuming? Naturalism and uniformitarianism. They're assuming that they know the initial conditions of these heavy elements, the initial amount of uranium to lead, and they're not just making an arbitrary guess. They're trying to do it intelligently. I'll give them that. There are what's called isochron methods, where you can try to estimate the initial ratio of parent to daughter element. I get that. But the fact is, you don't really know. Even isochron methods will give inconsistent ages, which means they can't both be right. You're still making the assumption that the decay rate's always been constant. And I think that ignores the rate research. The rate research is compelling evidence that the decay rate's not constant. Because again, you have an enormous amount of helium in these rocks that you say, well, that's produced by radioactive decay over billions of years. Well, if it was produced over billions of years, the helium would have escaped. It would be gone. Because helium's slippery. We've measured the rate at which helium slips through rocks, and it's fast. It doesn't take billions of years. So I think anyone who wants to argue that, again, it goes back to circular reasoning. They're assuming millions of years. They're assuming uniformitarianism. They're assuming naturalism. And they're saying, see, the evidence is consistent with that. And I would point out, but that doesn't really prove anything. All that proves is consistency. And in some cases, it's not consistent. Like when you find helium in these rocks, the helium would be gone if they were billions of years old. So it goes back to what we talked about earlier. They're not doing a reductio ad absurdum. They're assuming their own worldview and showing that in some cases it leads to consistency. but that's not a proof. A wrong worldview sometimes makes correct predictions that are consistent with the data. That doesn't prove it's right. All it takes is one inconsistency to prove that that model is wrong. And we have many inconsistencies with that model. So radioactive decay is the number one. And we've answered that. We've pointed out that you've assumed the uniformitarian assumption that the decay rates are constant. We have good evidence to the contrary. The other one that, and scientists don't use this so much, well, astronomers don't, but laymen do, is they think distant starlight proves. And of course, we've talked about that on other episodes of this, so I won't go into detail on that. But again, they're making the assumption of isotropy, that the speed of light's the same in all directions and it's one-way trip. Einstein says you can't do that. That's a stipulation. It's not an assumption. So that's and good physicists know that. Physicists who are very well versed with relativity, and they have to be very well versed with relativity, they would know that the one-way speed of light is a convention. It's not something that's measurable. It's stipulated. So that's not a proof either. So the two most used, radioactive decay and distant starlight, neither one of those requires an old universe. The evidence is perfectly consistent with a young universe for those two.
Just to let everyone know, the episode that Dr. Lyle's referring to is our distant starlight interview, and that was, in my opinion, I know I'm a little biased on it, but in my opinion, that was one of the most comprehensive interviews ever done on distant starlight. I can understand why it's so popular on the internet. But if y'all haven't seen the distant starlight video, please watch that. We go into tremendous amount of details on that. We talk about other views, other models, and things like that as well. So that was a very good discussion that we had on distant starlight. But yeah, so relativity shows that we can get light here within the biblical time scale. Just people that don't understand relativity typically bring up the distant starlight issue.
Yeah, yeah.
Um, all right. Let's see. Okay. Wait. Do you want to talk about ice cores?
Sure. So with ice cores, you take a section of ice and basically a cylinder. You take a hollow cylindrical tube and you put it down inside ice in Antarctica or someplace like that, and pull it up, and you'll find that there are like rings in it, and some of them are even visible. You can count the rings, and these are thought to be annual rings. So because places like Antarctica, even though it doesn't have the same kind of seasons we have, it has if you're in certain regions, it has 6 months of light, 6 months of darkness, and it does affect the weather. And so the idea is these are annual. And so, during certain seasons, you'll get darker bands, other seasons lighter, and so on. And you count them, and you can count the number of years. That's cute, but it's a storm will affect that. If a storm comes through, it can create a layer all by itself. And so there are these extra layers there that are not annual. So you got to be careful about that. That's one thing you got to be careful of. And then secondly, the layers become less distinct as you go deeper into the ice core. They fade over time, apparently. And so what they do at a certain point, they stop counting layers and they say, well, there's been this many layers in this section. We'll assume there's that many. You might say, well, they assume there's that many layers in that section. But in fact, they don't quite do that, because the assumption is this snow has been piling up in Antarctica for millions of years. And in millions of years, they think, well, it ought to flatten out, right? And so you'd think that these ice layers, which are no longer easily seen, would be compressed over time. And so they factor that in. But if you're paying attention, they've already assumed the millions of years, because they're assuming these get compacted in, right? And so they're saying there's actually a lot more in that layer and even more in that layer. And so when you get the millions, well, there's millions of layers. That's an assumption. It's an assumption that there are actually millions of layers there, because you can't see them distinctly beyond a certain point. They get fainter as you go on. They fade with time. And then secondly, the assumption is that they've been compressed by enormous factors, which assumes the millions of years, the very thing they're trying to prove. So ice cores don't tell you the age of something. You might be able to make an estimate if you limit it to the top layers where you can distinctly see the layers, but once you get beyond a certain level, they get very hard to see. In some cases, they can measure, I think, even isotope ratios and things like that. That's interesting. But in terms of seeing the physical layers, you can't see them anymore.
Would they also be assuming that each layer represents a year worth of time, kind of like tree rings, where you just kind of
Yeah, Yeah, and like tree rings, you can get more than one in 1 year. We know that storms will affect that. So it's similar to tree rings, except with tree rings, they're distinct all the way to the core of the tree. So tree rings will give you an estimate of the age of the tree. It might be a little bit big because you can get multiple rings in 1 year. With ice cores, they fade the farther in you go. And so at some point they start making assumptions based on the amount of snow that's there, not on the amount of distinct layers that they can see in it. Michael Ord is the expert on that. He's actually done this kind of stuff. I haven't. So take a look at some of his stuff if you want the details for that. Mike Ord really is the expert on all things weather.
Right. When I get into the flood stuff, I'm gonna be trying to see if I can get him on my channel. Uh, and I'm hoping to get him on my channel for discussion on the Ice Age, which is a video.
Yeah, he is the expert on the Ice Age. He
Yeah.
is brilliant on that topic. Yep.
What are some arguments for the age of the universe that you'd advise others to avoid? Like examples like light in transit, sun losing mass, buildup of moon dust on the moon, rings of Saturn moving away. I've heard of several other types of arguments, and I know you don't normally use these kind of arguments. So,
Right.
could you speak to that? Just kind of help other creationists
Sure.
know, you know, discernment.
Sure. Yeah. Yeah. So yeah, and I think the ones you listed are good arguments to avoid. The idea that the way that God got the light from the stars to here is God made the beam of light connecting the star to the earth, um, but otherwise assuming the Einstein synchrony convention. I think that's a mistake because if that's the way God did it, then stars that we've seen stars that have exploded that are beyond 6,000 light years. And if you say, well, no, God just made a picture of a star exploding in a beam of light, then it means the star never existed and never exploded. It was just a picture that God made in a beam of light. Can God make beams of light? Certainly. Is he going to put movies of fictional things that never happened in a light beam? I don't think God would do that. I think that's inconsistent with his nature. And it's not necessary to solve the starlight issue anyway. We have much better explanations that allow that what we're seeing actually happened. God made our eyes to see what's actually there. Granted, they can be fooled. I understand, there's optical illusions. Our eyes aren't perfect, maybe because of sin and the curse, or maybe just because we're finite. But nonetheless, God is not the author of confusion. So I don't think he's going to make movies of things that never happened. So supernova 1987A, I believe that was a real star that really blew up, and we saw it in 1987. And in my view, it happened in 1987 because I hold to the anisotropic synchrony convention. But in any case, I think making the light beams in transit is not a good idea. It makes God the author of confusion, which the Bible says he isn't. So I think that's not a good model. The sun, or maybe the sun, well, the sun does lose a little bit of mass, but it's trivial. One of the arguments that I've heard is that the sun is shrinking, and therefore in the past it would have been huge and would have been touching the earth or whatever. Not a good argument. Not a good argument. The evidence is that the sun, if it's shrinking at all, it's minuscule. It's not at a rate that even over billions of years would have a huge impact. I use the SOHO spacecraft, which measures the sun very precisely, and if it were shrinking at a noticeable rate, at a rate that SOHO could detect, that how do I say this? If the sun were shrinking so catastrophically that it would be gone in billions of years, or that it would have been enormous in the past billions of years, SOHO would have detected it. SOHO is accurate enough to be able to do that, and we have even more accurate instruments now. The Solar Dynamics Observatory, which is SOHO's kind of replacement, we would see that it's not there. Or missing neutrinos. That was an argument that used to be offered sometime in the past. Is that we only get 1/3 the number of neutrinos from the sun that were expected on the assumption that the sun is fusing hydrogen and helium. And one of the natural possibilities for that is that maybe only 1/3 of the sun's energy is powered by fusion, and the other 2/3 are powered by gravitational collapse. And that kind of went hand in hand with the shrinking sun hypothesis. But that was a reasonable thing to propose at the time, but we now have good evidence that the sun produces exactly as many neutrinos as it's supposed to if it's 100% powered by fusion. The reason the older detectors couldn't detect them is because older detectors can only detect one of the three kinds of neutrinos. And neutrinos have the ability to oscillate. They can change from one kind into another, from one variety into another. The newer detectors can detect all three varieties. and they detect all the neutrinos that the sun should be producing if it's 100% powered by fusion. So missing solar neutrinos is not a good age argument. And I actually wrote up an article on that years ago, decades ago, even before I was formally in full-time ministry. We have the buildup of dust on the moon. It's not that this is necessarily wrong. It's just that the problem is, here's the argument. The argument is, dust is accumulating on the moon, which it is. Moon's moving through space. There's a little bit of dust in space, falls on the moon's surface due to gravity. Moon accumulates dust. The argument was there should be hundreds of feet of dust on the moon if it's billions of years old, but we've landed on the moon and there's only like 1.5 inches of dust, and therefore it's thousands of years old. That sounds pretty good. The problem is we don't actually know the rate at which dust accumulates on the moon. If we knew the rate, then we could calculate. We could say, yeah, over billions of years, hundreds of feet. And back in the 60s, we thought we knew the rate, but that's been challenged lately. We're not sure what the rate of dust accumulation is on the moon. And therefore, that doesn't prove the moon is young. It doesn't prove the moon's old either. What it proves is that we can't use the dust on the moon to argue for the age one way or the other, because we don't know the rate at which it accumulates. We know the amount that's there. We don't know the rate at which it accumulates. There are arguments of the rings of Saturn, which actually, the rings of Saturn actually spiral inward, and they lose a little bit of energy on each orbit due to tidal forces. So they're spiraling inward. Now, most secularists would admit that that demonstrates the rings of Saturn are recent. And so if you want to make that argument, that's okay. You could say the rings of Saturn are not billions of years old. And most secularists would agree with that. There might be some who would hold out, but most of them would say, yeah, based on tidal forces, rings spiral inward. They do, just due to tidal forces. But the mistake that some creationists make is they say, see, therefore the solar system's thousands of years old. Got to be careful about that. All that demonstrates is that Saturn's rings are recent. There are many secularists who would admit that. They'd see Saturn's rings are recent, but the planet's billions of years old. The rings were probably created a few 100 million years ago when two moons collided, or asteroid collided with the moon or something like that. So you can have recent rings without having a recent planet. So you just got to be careful how you use that argument. So those are some examples right there of arguments that we would not use for a young universe or young solar system.
In the case of the moon, if you don't know the rate of something, it's kind of hard to use the reductio ad absurdum with that, because you don't
Yeah,
really know what the rate is anyhow.
right.
All right. All right. Okay, we reached the end of our discussion together. What are some final words you want to leave everyone with? Other creationists are encountering these arguments out there. They're encountering evolutionists, they're encountering old Earth creationists, and they're encountering these people. They are using these kinds of objections to say, the Earth can't be young, or because look at this data over here on radiometric dating, this in Starlight, and that sort of thing, and say, oh, well, science just proves that the Earth is young. I mean, could you speak to that, and so you can leave something with, because creationists are going to come out there and they're going to encounter these kinds of friction in terms of their viewpoint.
Yeah, so a couple of things to keep in mind. First of all, we've got the Word of God. Have confidence in it. That's my main thing that I want to encourage creationists. Have confidence in God's Word. A lot of those older arguments, because there was a time when we didn't know what the answer to radiometric dating was. That was before the Rate Research Initiative, before they had found this helium in biotite, in these zircon crystals, and found that no, the helium would be gone if they were billions of years old. So that suggests that the rate of radioactivity has increased in the past. There was a time when I was in grade school, they said, yeah, the nice thing about radioactive decay, you can't change it. You can't speed it up. You can't slow it down. That's what makes it such a good age indicator. We now know that's false. The uranium-osmium reaction. Rhenium decays into osmium. It's a radioactive decay. We've been able to speed that up in a laboratory by a factor of over 1 billion. So we know that radioactive decay can be sped up. So my point is, these things that in the past looked like they were really good evidence, what it took was further evidence that was discovered in science to make you realize, you know what, the Bible had it right all along. So if you don't want to have egg on your face, you better start with Scripture. You better admit God knows what He's doing, And if there's something that seems contrary to God's word, just wait, because we'll discover new evidence that'll overturn that. It's always the case, always the case. A lot of the stuff in astronomy, it seemed like the secularists had these really impressive models that at least maybe they didn't make too many predictions, but at least they were consistent with the data. That was before the James Webb Space Telescope was launched. We creationists had some different ideas, and there was no way to test it because for nearby galaxies, we made the same predictions as the secularists. It was, yeah, but once we get beyond this distance, the secularists said, we'll start seeing baby galaxies way out there. And we said, no, you won't. You'll see fully formed, mature galaxies. James Webb Space Telescope comes along. The creationists are right. Secularists were wrong, dead wrong. And we've now got some new evidence from the James Webb Space Telescope. I've got some new articles on the website on this. I've got a technical paper that I've published on this in the peer-reviewed literature that talks about the angular sizes of these galaxies being consistent with just the galaxies moving through a non-expanding space. Really neat. So the universe is expanding, but not in the way we thought. It's the fabric of space doesn't go with it. And based on that, I'm able to make quantitative predictions about what James Webb will find next. I predict that when it finds galaxies at these far redshifts, redshift of 18, redshift of 20, 22 maybe, the angular diameter will be, on average, 0.2 arc seconds. And the Big Bang predicts 10 times larger angular diameter because there's a magnification effect that kicks in if the fabric of space expands. So there you go. We're making testable predictions. We've got models out there. It's the creationists now who are doing the real research. It's the creationists who are making specific predictions, now quantitative predictions, about what will be discovered in future James Webb Space Telescope observations. So if you want to be right, get on board with what God's word says. You'll have an enormous advantage. That's what I would encourage people with today.
Awesome. That's actually advice that I give people whenever someone asks about critics stacks, because Christians aren't gods. We don't have all the answers, and sometimes we might not have all the answers at the time that the objection is brought up, and some things just it would take further research and of course we look into these matters and that sort of thing, like the so-called heat problem. There's still creationists just still looking into it and that sort of thing. But I always tell people wait because if you wait long enough, the critics always wind up shooting themselves in the foot because they always jump the gun, assume that they're right, and then some other data later, and the next thing you know, the critics themselves are contradicting themselves.
Yep.
So
Yep.
they
That's
always
the,
end up
that's the way
shooting
of
themselves
things.
in the foot in the end. But all right, thank you again for your time. I can't wait to see your discussion with Donnie Bedinsky on Standing for Truth on August 12th. I'm one of the moderators on this channel, so you'll see me in the comments.
All
So
right.
thank you again. I appreciate it. Uh, I guess that's it, unless you have something else to add.
Nope. Thanks for having me on. Appreciate it.
All right, no problem. Thank you. God bless.
You too.
Thank you for watching Apologetics 101. This has been an excellent discussion on the age of the universe, and and it rolled over into some things on the age of the Earth, and we went over a lot of arguments. And this has been a very, very good discussion. Um, Definitely don't forget to subscribe to my channel if you aren't subscribed. There's a lot more in store. Don't forget to hit that notification bell as well, and to give the video a thumbs up to help the uh, video get out there to more people. And also, I've got other interviews already scheduled. Dr. Georgia Purdom interview was supposed to happen yesterday, but some other thing came up, and so we end up having to postpone it until next week. But it's still happening. The first episode of my new series, Are We Apes, still going to be happening this month. I'm also in a couple days due to do an interview with Dr. Carl Werner concerning living fossils, which is going to be another episode of the Genesis series. And don't forget, I also have a live interview with Jennifer Niza at the end of this month. That's just going to be a normal episode of Apologetics 101, but it's going to be a deeply spiritual episode. It's going to have some apologetic implications concerning the supernatural. But Jennifer Niza used to be a former psychic who's now converted to Christianity and speaks out against the New Age movement. And so we're going to have her doing a live interview toward the end of this month called Out of Darkness. And we're going to be discussing Jen's testimony as well. And so we're going to have a great discussion on that. It's going to be live by a StreamYard. So don't miss that as well. That'll be toward the end of the month of August. And so I hope to see y'all there. And remember, always stay in the know.